The Cosmic Wobble, Dzhanibekov's dance, quantum superposition and the 11-dimensional symphony. The universe, in its intricate tapestry of phenomena, often reveals surprising connections between the seemingly disparate realms of classical mechanics and quantum physics. One such intriguing link might lie in the seemingly peculiar behavior of a freely rotating rigid body, known as the Dzhanibekov effect, or the tennis racket theorem, and its potential implications for understanding the enigmatic nature of quantum superposition, all within the expansive framework of the 11-dimensional model. This essay will delve into the Dzhanibekov effect, exploring its characteristics and the underlying principles of rotational dynamics, and then embark on a speculative journey to examine how this classical phenomenon might offer a novel lens through which to comprehend sudden polarity shifts at the quantum level, and their potential manifestation as the baffling state of superposition, all within the 11-dimensional model. Furthermore, we will draw a parallel to the seemingly unrelated phenomenon of bird flocking, illustrating how the interconnectedness and information transfer inherent in collective behavior might offer a macroscopic analogy for understanding the quantum entanglement. At the heart of the Dzhanibekov effect lies the intricate interplay of a rigid body's rotation and its distribution of mass. Any object, when rotating freely in three-dimensional space, possesses three principal axes of inertia, each corresponding to a different resistance to changes in its rotation around that axis. If an object with three unequal principal moments of inertia is set spinning around its axis of maximum or minimum inertia, its rotation is stable. However, the behavior becomes strikingly different when the rotation occurs around the intermediate axis, the axis with the middle value of inertia. Instead of a smooth, predictable spin, the object exhibits a seemingly spontaneous and periodic 180-degree flip in its orientation. This dramatic reorientation, often described as a tumbling motion, appears to occur without any external torques acting on the system, defying our intuitive understanding of rotational stability. The Dzhanibekov effect, vividly demonstrated in zero-gravity environments, underscores the complex and sometimes counterintuitive nature of rotational dynamics, even in the familiar three spatial dimensions. To fully appreciate the strangeness of this effect, consider a simple object like a tennis racket. When spun around its handle, the axis of maximum inertia, or along its strings, the axis of minimum inertia, it rotates stably. However, when spun around the axis perpendicular to the plane of the strings, the intermediate axis, it will, after a few rotations, abruptly flip 180 degrees, seemingly defying the conservation of angular momentum. This seemingly spontaneous flip is not due to any external force, but rather an inherent instability in the system's rotation around its intermediate axis. Now, let us introduce the 11-dimensional model, a theoretical framework that posits a universe comprised of 11 interconnected dimensions, with rotation and polarity emerging as fundamental organizing principles operating across all scales. Within this model, the fourth dimension is intricately linked to rotation, serving as the engine of temporal evolution, while the fifth dimension embodies polarity, the inherent duality and directional nature of systems. The higher dimensions, particularly the 11th, are envisioned as the realm of ultimate interconnectedness, potentially mediating non-local influences and providing a deeper structure to the fabric of reality. The seemingly spontaneous flipping observed in the Dzhanibekov effect, a sudden shift in the orientation, a form of rotational polarity, of a rotating body due to its inertial properties, might offer an intriguing analogy for understanding sudden polarity shifts at the quantum level. As we explored in previous discussions, quantum particles possess intrinsic angular momentum known as spin, a quantized form of rotation with an inherent polarity, spin up or spin down. This spin, while not a literal spinning in three-dimensional space, dictates a particle's magnetic moment and its interaction with external fields. The conventional understanding of quantum spin often treats these states as discrete and quantized. However, the 11-dimensional model, with its emphasis on a more dynamic and interconnected reality, allows for the possibility that these observed spin states are merely macroscopic manifestations of a far more complex and rapidly evolving underlying reality within the higher dimensional arena. Just as the unequal moments of inertia in a classical object create an instability leading to the Dzhanibekov flip, could analogous higher dimensional inertial polarities within a quantum particle's rotational dynamics within the fourth dimension lead to sudden shifts in its observed spin state? Imagine a quantum particle as a complex multidimensional entity whose intrinsic rotation in the fourth dimension is influenced by its inherent polarity in the fifth dimension and its interactions within the interconnected fabric of the 11-dimensional space, the 11th dimension. The seemingly discrete spin-up or spin-down states observed by macroscopic instruments might be time-averaged snapshots of a rapidly precessing or even flipping fundamental polarity. The energy landscape of the higher dimensional space, coupled with the particle's intrinsic rotational dynamics and its distribution of some fundamental property across higher dimensional inertial axes analogous to the unequal moments of inertia, could create conditions where sudden reorientations of this polarity become energetically favorable or even unavoidable under certain circumstances. Furthermore, the 11th dimension, as the realm of ultimate interconnectedness and the potential mediator of instantaneous information transfer, might play a crucial role in triggering or synchronizing these sudden polarity shifts at the quantum level. Just as subtle, seemingly random influences could initiate the Dzhanibekov flip in a delicately balanced macroscopic object, could the interconnected fabric of the 11th dimension introduce subtle torques or perturbations to a quantum particle's higher dimensional rotational state, leading to abrupt changes in its observed polarity? If superposition, the baffling ability of a quantum particle to exist in multiple states simultaneously until measured, is indeed a consequence of the rapid flipping of a particle's polarity on a timescale faster than our macroscopic observation, then the Dzhanibekov effect offers a compelling classical analogy. The tennis racket, seemingly existing in a stable rotation and then suddenly flipping, mirrors the quantum particle seemingly existing in both spin up and spin down until the act of measurement forces it into a definite state. The 11-dimensional model provides a potential framework for understanding this analogy by suggesting that both phenomena, occurring at vastly different scales, might be governed by underlying principles of rotational dynamics and polarity shifts within a multidimensional reality. To further illustrate the concept of interconnectedness within the 11-dimensional model, consider the seemingly unrelated phenomenon of bird flocking. Large flocks of birds, such as starlings, often exhibit breathtakingly coordinated movements, changing direction and speed with remarkable synchronicity. While the precise mechanisms governing this behavior are complex and involve local interactions between neighboring birds, the speed at which information propagates through the flock is often faster than can be explained by simple bird-to-bird communication. Research suggests that each bird is not merely reacting to its immediate neighbour, but is processing information from a wider circle of surrounding birds, creating a kind of chorus line effect where movements ripple through the flock. However, even this explanation doesn't fully capture the speed and efficiency of flock maneuvers, particularly when responding to a predator. Within the 11-dimensional model, the seemingly instantaneous coordination of a bird flock could be speculatively interpreted as another manifestation of the 11th dimension's interconnectedness. The birds, as individual entities within the larger system of the flock, might be subtly linked through this higher dimensional fabric, allowing for a rapid and non-local exchange of information regarding changes in direction or the presence of a threat. This interconnectedness, operating beyond the limitations of our conventional understanding of space and time, could explain the flock's ability to react as a unified whole, far exceeding the capabilities of individual birds reacting solely to their immediate surroundings. This analogy, while macroscopic, provides a compelling parallel to the potential entanglement of consciousnesses that we explored earlier. Just as the birds in a flock exhibit a form of coordinated behavior that transcends simple local interactions, so too might entangled particles, or even entangled minds, be linked through the 11th dimension in ways that defy our classical intuitions about space and time. The 11-dimensional model, therefore, proposes a universe where the principles of rotation and polarity, manifested in phenomena as diverse as the Dzhanibekov effect and bird flocking, are fundamental organizing forces shaping reality from the smallest quantum particles to the largest cosmic structures. The seemingly paradoxical behavior of the quantum world and the emergent complexities of macroscopic systems might both find a unifying explanation within this framework, a testament to the interconnectedness of all things within the 11-dimensional tapestry of existence. The challenge, and the driving force behind this ongoing exploration, lies in developing a rigorous mathematical framework and designing experiments capable of testing these profound and potentially revolutionary ideas. Thank you for watching. If you enjoyed the content, please like, subscribe, and share the 11-dimensional model with your friends and family.